You know that feeling, right? You finish a killer run, maybe a tough bike ride, you're feeling pretty good. You check the app leaderboards and then bang,
Hmm.
someone's posted a time that just seems impossible. Makes you wonder if they had a secret motor or maybe just drove part of it.
Oh, yeah, that's a classic frustration for anyone who takes platforms like Strava seriously. Seeing those, let's say, questionable times can really, well, take the wind out of your sails when you're putting in real effort.
Well, today, we're actually tackling that exact thing head on. We are diving deep into Strava, which I know loads of you learners use for tracking your runs and rides. We're looking at how they work behind the scenes to try and keep those leaderboards, reasonably honest. Specifically, how they find and remove activities that look like they got a little help from an engine.
Exactly. Cars, motorbikes, maybe even trains or planes showing up on segments. We're going to explore the tech, the processes Strava uses to try and level that playing field.
It's really about understanding how a huge platform like that deals with data integrity when, let's face it, so much of the data comes directly from users.
And the challenges involved.
And this whole topic really jumped out at us thanks to a great piece over on the 5K Runner website. They've got an article called How Strava Removed Cars from Leaderboard Performances.
Yeah, the 5K runner. They clearly get the running and cycling world, and their take really highlighted how much effort Strava puts into this.
Yeah, their passion for fair competition definitely came through. It made us realize there's a lot going on under the hood, so to speak, at Strava that most users probably don't see.
Definitely. That article really emphasizes that cleaning up leaderboards on this scale isn't a one-off fix, it's a constant battle.
So our mission for this deep dive,
Yeah.
figure out how Strava actually spots these motorized activities. What tech are they using? What are the methods? And what makes it so tricky? Okay, so first up, Strava has this thing called the Cars on Segments model. What exactly is that?
So think of this model as like Strava's automatic bouncer for the leaderboards. It's built specifically to try and identify any run or ride that might have involved a vehicle, car, motorbike, train, you name it.
Okay, like a filter.
Yeah, precisely. And what's quite interesting is that every single activity, run or ride, that gets uploaded goes through this model first. It's like a universal screening process.
Wow, every single one. That must be a massive amount of processing power humming away in the background.
It really is.
So what does the model actually produce? What's the output?
Well, it generates a probability score for each activity. It's a number between 0 and 1. Basically, it's the model's best guess on how likely it is that a vehicle was involved.
0 means probably, okay, 1 means suspicious.
Pretty much. 0 is like, yeah, let's human-powered, and closer to 1 means, this looks fishy, might be a car involved.
And if it gets a high score, a score near 1, does it just get kicked off the leaderboard straight away?
Not immediately, no. They use what's called a classification threshold. If the probability score goes above that threshold, the activity gets flagged. But crucially, this happens before it ever shows up on a public leaderboard.
Ah, okay. So it stops it getting there in the first place.
Right. And then the user who uploaded it gets a notification. It prompts them, saying something like, hey, this looks like it might have vehicle assistance. It gives them the option to either crop out the part where they were in a car, maybe they forgot to turn off the recording, happens all the time.
Oh yeah, I've done that.
Exactly. Or they can just make the whole activity private so it doesn't affect leaderboards at all. It handles those honest mistakes pretty well.
That does sound fair. Okay, but the really juicy part is how it calculates that score. The 5K Runner article mentioned Strava looks at 57 different features. That sounds intense.
It is pretty detailed. These 57 features are basically different measurements and calculations derived from the GPS data, the elevation data, the time data of your activity.
Like what kind of things?
Well, some are fairly straightforward, your average speed, how much your speed varied, your average acceleration, variance in acceleration, things like that.
Standard stuff.
Yeah, the basics. But then it gets more complex. The 5K Runner article pointed out things like jerk.
Jerk. Like sudden movements. What's that tell you?
Yeah, it sounds funny, but it's a physics term. It's the rate of change of acceleration. So not just how fast you're speeding up, but how quickly that acceleration itself is changing.
Okay, why does that matter?
Well, think about it. A car often accelerates smoothly and consistently, right? Whereas a runner or cyclist, their acceleration might be much more variable, bursty, jerky even. So analyzing jerk helps distinguish those patterns.
Huh, interesting. What else? You mentioned something cycling specific.
Right. Another complex one, particularly relevant for cyclists like the 5K runner tracks, is average VAM on climbs.
VAM. Remind me.
Sure. VAM stands for Velocità Ascensional Media. It's basically your vertical climbing speed, how many vertical meters you gain per hour.
And there are limits to that for humans.
Exactly. There are pretty well understood physiological limits to how fast even the best cyclist can climb a steep hill purely on leg power. So if the activity data shows a VAM that's like way off the charts for human capability, that's a strong indicator. The model also considers the gradient of the slope and how momentum might play a part.
Okay, so it's building a complex picture.
Mm.
Now, the 5K runner article also really highlighted something called the Sendrix coefficient. Sounds like something out of a spy movie.
It does sound cool, doesn't it? It's
Oh.
actually a really clever feature Strava developed internally. They named it after one of their own employees, Jimmy Sendrix, who's apparently a very fast cyclist.
Okay, so what did Jimmy do?
They basically studied his performance data, specifically how quickly he could accelerate from a dead stop up to 20 miles per hour, and crucially, how many times he could repeat that kind of hard effort before fatigue inevitably set in.
Ah, so they're using a real athlete's limits as a kind of benchmark.
Precisely, because that's a key difference, isn't it? A car can accelerate quickly from 0 to 20, stop and do it again and again and again with no drop-off in performance.
Right, cars don't get tired.
Exactly. But even a top cyclist like Jimmy Sendrix will start to fatigue. Those bursts of acceleration will likely become less frequent, maybe less powerful over time. The Sendrix coefficient helps the model look for that pattern or the lack of it. Consistent, repeatable, high acceleration points towards a vehicle.
That's genuinely smart, using human fatigue as a data point. Okay, the article also threw around XAI, SHV values. That sounds even more technical. Break that down for us.
Right, XAI just stands for Explainable Artificial Intelligence. The big idea is making these complex AI models less of a black box, making their decisions understandable.
Okay, explainable AI. Got it. And SHAA.
SHAP stands for Shapley Additive Explanations. It's a specific technique within XAI. Think of it this way. For every one of those 57 features we talked about, the model uses SHAP values to assign a sort of weight. This weight indicates how much that specific feature's value is pushing the final decision towards human-powered or towards vehicle-assisted.
So it's not just the final score, but why the model arrived at that score, like showing its work.
Exactly. It quantifies the influence of each feature. So the Strava team can see, okay, the high top speed contributed this much towards flagging it as a car, while the acceleration pattern contributed that much.
Can you give an example?
Yeah.
Like with top speed?
Sure. Let's say an activity hits 80 miles per hour. The SHAP value for that top speed feature would weigh very heavily towards vehicle. It's just not humanly possible on a bike, really.
Okay, clear cut.
But what if the top speed is, say, 25 miles per hour? Well, a fit cyclist could hit that downhill, but you could also easily be driving in traffic and not go much faster. So the SHAP value for that feature would be less decisive on its own.
Right, it needs more context.
Precisely. In that case, the model relies more on the SHAP values from the other 56 features, the acceleration, the jerk, the VAM, the Sendrix coefficient, all of it. It adds up all these weighted contributions to get the final probability score.
That makes sense. It's like weighing different pieces of evidence. So how did they train this model? The 5K runner mentioned it, learned from a lot of data.
A huge amount. The model itself is technically a gradient-boosted decision tree classifier. They use a common machine learning library called XGBoost, and they trained it on literally tens of thousands of Strava activities that had already been identified either by users or internally as definitely containing vehicle segments or being entirely recorded in a vehicle.
So it learned what car looks like in the data.
Essentially, yes. It learned the typical patterns and combinations of those 57 features that strongly indicate vehicle use.
And how good is it? The article mentioned an 81% success rate for flagging activities with vehicles. Is that good? It sounds like it misses almost 20%.
Yeah, on the surface, 81% might not sound perfect. But, and this is a point the 5K Runner article made, while actually distinguishing reliably between, say, a very fast e-bike, someone getting a draft from a car, or just a slow car journey, versus a human effort based purely on GPS and sensor data is really hard.
There are lots of gray areas.
Tons of gray areas. Think about poor GPS signals in cities, tunnels, someone riding an e-bike very fast, someone maybe drafting behind a scooter. Given that complexity, automatically catching 81% of the likely vehicle-assisted activities before they even pollute the leaderboards is actually, well, pretty decent performance.
Right, context is key. The article also mentioned Strava showed some visuals, like comparing the data trace of the bike ride versus a car. I bet those make it obvious sometimes.
They definitely can. Strava has shared examples where Yeah, the speed profile, the acceleration, it's just night and day between a typical bike ride and a car journey. The model would have an easy time with those. But they also showed trickier cases, like data from a pro cyclist in a race absolutely burying themselves. Their numbers might push the limits of what seems human, making it a harder call for the algorithm, and that's why having all 57 features is so important.
So it's clearly not a set it and forget it system. What's next? Is Strava continuing to work on this? The 5K runner mentioned future plans.
Oh, definitely. They're very open about it being an ongoing process. One thing they're working on is a model specifically to stop bike rides being wrongly classified as runs. That's a common annoyance, right? Messes up running leaderboards.
Yeah, that happens a lot.
Another big one is a dedicated model to better differentiate between e-bikes and regular bikes. E-bikes are great, but they belong on their own leaderboards.
Makes sense. Keep things fair.
And maybe the most ambitious plan, which the 5K runner would surely approve of, is their goal to retrospectively reprocess every single top 10 result on every Strava segment.
Wow, every top 10 ever.
That's the plan. To go back and apply these improved models to weed out any lingering vehicles, misclassified activities, or e-bike results from the historical records, it's a massive cleanup job.
That shows some serious commitment. But as the 5K runner noted, Strava themselves say it won't be perfect.
And that's a realistic and important point they make. Given the data challenges, the edge cases, achieving 100% accuracy automatically is probably impossible. But they're clearly investing heavily in getting closer and being transparent about the limitations.
And this cars on segments model isn't the only thing they're doing for leaderboard health, is it? There was mention of segment updates, too.
Yeah, that's right. They have a broader effort they call segment decluttering. They're trying to tidy up the sheer number of segments out there.
Yeah.
They're actively removing duplicate segments. You know how sometimes there are 5 versions of the same climb? And also getting rid of old segments with really bad GPS data that aren't really used anymore. They mentioned removing something like 610,000 duplicate segments already.
Whoa, 610,000. That's a lot of digital tidying up. What about people's achievements on those deleted segments? Do they just vanish?
No, thankfully they thought about that. When they remove duplicates, they designate one as the main segment and automatically migrate things like your personal records, PRs, your starred status, and any goals you had set from the duplicates over to the main one.
Okay, so you don't lose your history? That's good.
Mostly, yes. The caveat is if a segment has really bad GPS data and maybe has to be made private or significantly altered, you might lose achievements tied specifically to that very poor data, but they're trying to minimize that, especially for popular segments.
And they're also adding verified segments. What's that about?
Yeah, that's a cool initiative. It's about adding a sort of official stamp to the most iconic or popular segments. These get a little verification badge.
Like a blue tick for Strava segments.
Kind of, yeah. It means Strava has checked the distance and elevation game for accuracy, and it's recognized as, like, the definitive version of that climb or stretch of road. Helpful if you're targeting a specific, well-known challenge, something the 5K runner probably values on key routes.
How do segments get verified? Do you apply?
It seems to be mostly based on popularity metrics, how many people attempt it, star it, set goals on it, and also its significance, like famous Tour de France climbs or major marathon sections. User engagement, like starring, definitely helps flag important segments. There are about 500 verified worldwide right now.
Okay. And then there's the leaderboard cleanup. That sounds directly related to those crazy times we started talking about.
It is. This involves using their upgraded auto-flagging systems, including the improved Cars on Segments model. They expect these upgrades to catch significantly more bogus efforts. They estimate removing 33% fewer impossible results on cycling leaderboards, which actually means catching more bad ones.
Fewer impossible results, meaning the leaderboards get cleaner.
Exactly. It's a bit confusingly worded, but the outcome is better leaderboards. And importantly, they're applying this improved flagging to older activities too, gradually cleaning up the historical data.
That's good news for anyone scrolling back through old results. And it's not all automated, right? Users can still flag things.
Absolutely. The community flagging system is still there. If you see an activity that looks suspect, you can report it via the website. It acts as another important layer of quality control.
So it really sounds like a multi-pronged attack.
Mm-hmm.
Sophisticated AI, manual cleanup, community reporting, segment verification. It really drives home the point from the 5K Runners article about how complex maintaining fair leaderboards is on such a huge user-driven platform.
It absolutely does. And with things like e-bikes becoming more common, and just the inherent fuzziness of GPS data sometimes, perfectly telling everything apart automatically is, well, it's an ongoing technological race, really. Requires constant updates and refinement.
Well, this has been genuinely fascinating. A real look under the hood at Strava, prompted by that excellent piece from the 5K runner. It's amazing how much tech goes into what seems like a simple leaderboard feature.
It really is. It highlights the complexity behind these platforms we use every day and the constant effort needed to maintain trust and fairness in these huge digital communities built on user data.
And for you, the learner, hopefully, that gives you a much clearer view of the sophisticated systems running behind the scenes of your fitness app. It really shows the challenges of keeping data reliable when millions of people are uploading activities every day.
Yeah, and it leaves us with a final thought to chew on. As AI gets more and more integrated into everything we use, how does our understanding, or maybe our lack of understanding of how these systems work, affect how much we trust them? Especially on platforms where there's an element of competition, like Strava, it really makes you think about that balance between powerful algorithms and the human side of things in these shared digital spaces.